Let's look at this question. Find the value of x for which the following function is discontinuous. Now, remember, one way to see whether a function is discontinuous is to see if you're being asked to divide by 0. You know that dividing by 0 is indeterminate. So this function would be discontinuous for x squared minus 4 equals 0. Because that would mean you have x cubed plus 8 divided by 0. Alright? That makes it discontinuous. Now, let me draw a line here to separate the function and the working out. If x squared minus 4 is discontinuous, that means x squared is equal to 4. Add 4 to both sides, and then of course, when you square root both sides, the square root of x squared is equal to the square root of 4. Remember, you have a positive and negative square root of 4. So the square root of x squared is x, and the square root of 4 is 2, so it's positive and negative 2. So you have two square roots here, positive 2 and negative 2. So the value, or in this case, I should say values, since there are two of them, of x for which the function is discontinuous is x is equal to 2 and x is equal to negative 2. Alright? Now, here it says, hence or otherwise, find the limit as x tends to negative 2 of x cubed plus 8. Alright. Now, as you see, you can always factorize this part using a difference of 2 squares. You can factorize the denominator using a difference of 2 squares. So you're looking at the limit as x tends to negative 2 of x cubed plus 8 divided by x plus 2, x minus 2. Alright? So now, you remember the difference of 2 squares, the shortcut way of doing it, even though it can be done using the AC method by saying x squared, that's 1x squared plus 0x plus negative 4. But you have two brackets. On the left of each bracket you have whatever you squared to get x squared, which is x, and on the right you have whatever you squared to get 4, which is 2. Then you have a positive and negative 2. Alright? You have to remember the method of factorizing a difference of 2 squares. But how do we go about the numerator, x cubed plus 8? I'm expecting that there should be something at the top in the numerator that will be cancelled by the x plus 2 or cancelled by the x minus 2. Now, you can use a certain identity that is called the sum of cubes identity. Sum of cubes identity, which says that a squared plus, or a cube, I should say, a cube plus b cube, it is equal to a plus b, then open bracket, a squared minus ab plus b squared. Alright? Now, this, as I'm seeing, is an anomaly. it is asking you to use an identity, which I don't remember seeing in your earlier courses, whether algebra or pre-calculus, right? And your formula sheet for this or the course outline, I don't remember seeing this there. So I think that was an error putting this there in the paper without referring to the sum of cubes identity. All right, that is something that will have to be addressed for any future paper. But here, you can test and see whether it really works. If you multiply a plus b by a squared minus ab plus b squared, a times a squared is a cubed plus a times negative ab is minus a squared b plus a times b squared is ab squared plus a times a cubed. No, plus b times a squared, I mean. So a times a cubed would have been a times a squared, but b times a squared is a squared b. Then we would have b times negative ab is negative ab squared plus b times b squared is b cubed. And here, the negative a squared b plus a squared b is 0, that's gone. ab squared minus ab squared, that would go, leaving a cubed plus b cubed there. Alright, so you see that it does work. Alright, just want some reassurance that this thing is correct. Well, let's look at this now. X cubed plus 8. We're looking at the limit as x tends to negative 2. Limit as x tends to negative 2 of x cubed plus. Now, we want to write it as something cubed. We want to find out what is it that you cube to get 8. Well, it's b. It's 2. 2 2's 4, 4 2's 8. So it's x cubed plus 2 cubed, right? Over x plus 2x minus 2. Now, here, based on this identity, A would represent the x and B represent the 2, or I should say the x would represent the A from the identity. It's x cubed, you have x cubed, it's a cubed, so x is A, and you have plus b cubed, it's 2 cubed, so 2 cubed is a b cubed. So whatever you do with a and b here, you'll have to do with x and 2 here. So let's see what happens over here now. This is x plus 2, that's like the a plus b, and you have x squared minus 2x plus 2 squared. That's what you would have. And that's over x plus 2, x minus 2. You see that? This part, the x plus 2 plus 2, I mean the x cubed plus 2 cubed is like a cubed plus b cubed. A plus b, you have x plus 2. And then this part here. Now, let's see what happens after. Oh, look at this. X plus 2 cancels x plus 2. So what we have is a limit as x tends to negative 2 of x squared minus 2x plus 2 squared over x minus 2. So this is as x tends to negative 2. If you substitute negative 2 here in the function, or let's substitute 2. Oh, yeah, negative 2 it would have to be. Yeah, negative 2 squared, right? Minus 2 times negative 2, that's 2 times x, plus 2 squared over negative 2 minus 2. See that? You substitute for these values here. Let's work this out and see what we get. This is equal to negative 2 squared is 4. 2 times negative 2 here is plus 2 is 4 plus 2 squared gives you 4 divided by negative 2 minus 2 is negative 4. So up top 4 plus 4 plus 4, that would be 12 divided by negative 4. And you have here 4 into 12, negative 3. Alright, so that's one way of working it out, but you would have to know what the cube identity says. But another way you could look at it, right, without using the sum of cubes identity, is this. Now, you wouldn't need the sum of cubes identity, so that would make the question alright at this point. Choose a value that is close to negative 2 on the left and on the right. That means you have negative 2 here, you have negative 3, negative 4, and so on, negative 1, 0. Alright. Choose a value that's close. That's, say, negative 2.1 on the left, and on the right, negative 1.9. Let's see what would happen if we do that. No, it says hence or otherwise. So here, x cubed plus 8 over x squared minus 4. So the limit as x tends to negative 2 of x cubed plus 8 over x squared minus 4. Alright. Let x equal negative 2.1. What would happen? Negative 2.1 cubed plus 8 over negative 2.1 squared minus 4. Right? I said that earlier that there must have been a mistake in putting the question that way for you to know the thing there, the that identity, sum of cubes identity, but it came to mind that you could very well use a value closer and closer to it. So probably whoever set this question had that in mind for you to use that method. But anyway, it says hence or otherwise, so no problem. Negative 2.1 cube. What is that? Let's get our calculator. Alright. Negative 2.1 cube. Negative 2.1 raised to the power of 3 equals, so we have negative 9.261 plus 8, negative 9.261 plus 8 divided by, we have negative 2.1 squared, same as 2.1 squared, so to the power of 2. Oh, it says, it's saying 22.1. It double click here. Yeah, 2.1 squared is what? 4.41. Alright, so it's 4.41 minus 4 equals. Alright, so let's see what happens here. So we have negative 9.261 plus 8 close bracket divided by open bracket 4.41 minus 4 close bracket equal. Alright, so we have negative 3.07 something. Negative 3.07 something. What was the answer we got earlier? Negative 3. That's close. And then let x equal negative 1.9. Let x equal negative 1.9. What we would have then is negative 1.9 cubed plus 8 over negative 1.9 squared minus 4. Negative 1.9 squared minus 4 equals. Alright. So, using our calculator here, suppose we say negative 1.9 cubed plus 8, negative 1.9 to the power of 3 plus 8. Let's do it like this. Close bracket, close bracket, over open bracket, negative 1.9 square, same as 1.9 square, that's 1.9 to the power of 2, minus 4, close bracket, equal negative 2.925 something. Negative 2 point, call it negative 2.9. Now, it is approaching 3. Alright, you can see that. And suppose you choose to use negative, you're going close to 2. So suppose it was negative 0.999 cube plus 8. Negative 1.999 and 1.999 here. I didn't put a negative in front of this one here because, you know, when you square it, it turns out to be positive anyway. Let's see where this would go. It's even closer to 2 as it approaches 2, as it approaches negative 2. Let's see what happens. Negative 2.9999, very close to 3. So you can see the limit is 3. Alright? Negative 3, I should say. Limit is negative 3. So, one way to test the limit, unless you're told otherwise, is to use a value that gets closer and closer to x. Right? As in this case. So, you didn't really need to use the sum of cubes identity. You could just use a value that gets closer and closer to 2 because x approach, to negative 2 because it says x tends to negative 2. Oh my, yeah, as x tends to negative 2. Alright? So the limit is negative 3. So that's it for now. I'll see you in the next video.